Anton. I'm the CTO and the founder of SpiralScout. I have about 14 years of development experience. I code mostly on PHP and Golang, and I'm the author of Spiral Framework, Roadrunner, and Cycle ORM, which today I would like to explain in some details. In today's presentation, I would like to cover a couple topics, some of them lightly, some of them in a bit deeper details. I would like to start to walk through and remember why do we need ORM at all? What are the differences between the most common patterns, ActiveRecord and DataMapper? We will review what building blocks you need if you want to build your own ORM. We will see how we can implement the topological sorting and persistent layer in ORM. And at the end, I will review the feature set of the cycle ORM, which been used as foundation for this presentation. So the simple question which everyone asks themselves, why do we even need an ORM? The answers to these questions are fairly subjective. They vary from person to person, but probably the most common is it will help us to simplify communication with database. Instead of writing long SQL queries every time, you can just call the query builder, hydrate your models, and here we go, it all works. Though you still need to remember how SQL work, ideally learn it in every particular detail. In this case, ORM would not trick you. Every ORM will slow down your application. That's inevitable. This is a fairly fat abstraction. So by adding ORM, you have to remember that everything has a balance. So you can save on the development time, but you are going to lose a bit on the performance. Separately from the simplification of communication layer, it will also able to provide you some functionality to isolate your domain layer, your entities repositories from the persistence layer. And why do we need that? We need that because it will help us to test our application much easier. In the later examples, I will show how the testing vary from ActiveRecord and DataMapper. First, you probably all heard about these two patterns, ActiveRecord and DataMapper. That's unending holy war between people who love one of them and hate another. And to start, we can try to compare them. Some people might say that the difference between ActiveRecord versus DataMapper is the presence of method save. That's actually not true. You can add save method to your plain PHP models in any DataMapper, and you can ActiveRecord without having this method. Okay, maybe that's about the static method find versus repositories in data mappers. That's not true as well. You can still create engines which shows traits of both data mapper or ActiveRecord, but still lean towards one of the patterns. So the biggest difference between these engines lies within how they represent your data. While in ActiveRecord, your data is represent one specific row in a table, in DataMapper, that's not always true. One entity might represent multiple tables or even partial table, or it can be compound from multiple sources. The whole idea of DataMapper is that you don't think what's inside the database. You think only about your domain code and how this domain code mapped to the persistence database. The order of implementation varies as well. While in ActiveRecord, we usually start with migrations, creating models on the site, and that's how we end with working product. With DataMapper, we usually start with our domain layer, and we usually request DataMapper to create database for us. But again, it might vary, especially if you work with legacy databases. And obviously, both engines has very specific implementation details. So even comparing two ActiveRecords or two data mappers, you might find a million small differences in details which vary from implementation to implementation. If you review the classic setup of ActiveRecord, well, that's very simple. You have the database. You always need to have a DBL layer. Not always. In some implementations, you might skip it, but it's going to be much harder to develop complex relations. And then you map these columns, these rows from the database through DBL to the record. This pattern is very easy to write. You probably know tens of different ActiveRecords. It's fairly easy to created by yourself, so it's DOI friendly. The problems with these patterns is that you do need to remember the database schema by yourself. ORM does not help you. So if you rename the column in database, you need to go and rename the columns in your entities as well and change your code, which usually ends to the fact that systems like that are harder to maintain. And since the active record needs some way to represent your row, you're usually going to have the base model or GOT model, how it's called. In data mappers, we are going to add two additional layers. The layer number one is an entity map. That's some kind of memory repository of all the entities loaded from database. It contains the list of these entities and relationships between them. This is important so we know how they relate to each other and how we can persist them. In addition to that, the critical part of DataMapper, and you can see it by its name, is mapper, or the layer which is responsible for the conversion of data from the database to your entity. In many cases, it's not one-to-one, so you can have fields and properties named one way in your domain layer, and columns in database can be named another way. That's probably the biggest difference between two engines. Because the complexity doesn't go anywhere, you still have a full-featured ORM. It's still harder to maintain because you need to learn how to configure these mapping layers. You need to figure out how it works and how to debug it. And usually data mappers like that do not require base model. You can create flat PHP models, map to them, and here we go. So which one to use? Again, this very subjective question. I'm not going to give you answer for that, but the rumors are saying that ActiveRecord is the best for the smallest projects and prototypes, while DataMapper is for the hardcore enterprise. If I'll be creating my blog, I will definitely use ActiveRecord because it's faster to bootstrap, and if I'll be creating a huge CRM, that's going to be DataMapper. Why? Well, maybe some people will tell you that don't use ORM as well at all, and there is a lot of people who is doing that. But where are these rumors coming from? Why people say Record for small projects and DataMapper for enterprise projects? I think it all ends to the simple question, which is, what about testing? Most of the enterprise applications and enterprise development require developers to provide very complex test suite, which means we need to cover most of the business logic with unit tests or integration tests or etc. If you review this code snippet, which is done using DataMapper ORM, how can we test it? Well, fairly easy. We can mock the user repository and expect that we're going to receive the user ID, and we can mock the entity manager and expect that we're going to receive the user entity with added credit as array of objects. In this case, we trust ORM. We mock the abstractions it's provided to us, and we do not create any queries to the database. We still can, but it is not required. Our test is easy, it's simple, it's very fast to run, and it's reliable. Well, let's review the same thing for ActiveRecord, and I'm using some abstract ActiveRecord with some anti-patterns, but let's see, we have almost identical code, a user find by primary key, credits and save. So how can we test it? Well, that's a big question. We can try to mock the record. How? We can try to mock the repository if there are any repository, or maybe we can hook to onSave, and you see what I'm trying to show. We're probably going to forget about unit tests and create acceptance tests instead. We are going to use some stub database or SQLite in memory. And essentially, we do not trust the ORM. ORM becomes an essential part of our code base, which means every test, every iteration includes all the logic from within the ORM. So the practical differences after reviewing the tests and comparing them together are the following. They use different domain layer isolation approaches. Specifically, DataMapper isolates the domain layer using the mapper layer, and ActiveRecord does not. It simply becomes part of your domain layer. DataMappers are usually easier to test than ActiveRecord, but well, there are always scenarios when something is not true, so you can create code which is very hard to test on DataMapper. And ActiveRecords follows the database schema. So if you have to change the schema, you have to change your models in your code, while the DataMapper follows the mapping schema, which means you can freely change your domain layer, you can freely change your database, and you only need to adjust this mapping layer to make it work. And because ActiveRecord are easier to write, well, you usually have much wider choice of engines like that. If we review what we have on the market, we have that almost every major framework going to have its own ActiveRecord implementation. UE have it. Propel is Doctrina version 1 was ActiveRecord implementation. Obviously, Eloquent from Laravel. There is a number of ORMs which shows traits of both. Some of them use mapping layer, some of them use mapping layer plus base model. So I would call them hybrid. And obviously there is a huge variety of DataMapper ORMs for the PHP. Well, plus cycle, which I will try to explain today. Doctrina, that's Doctrina if people don't remember. So let's say that you decide to build your own ORM, specifically DataMapper, and what do you need to do that? First, you need a DBL, database abstraction layer, ideally the layer which is capable of introspection and schema declaration, meaning it can read the schema of your database, compare it, and create migrations for you. You can use, you have a variety of them on the market. Popularest one are from Doctrina. You will need a query builder, query DSL, or DQL, how it's called in Doctrina, or some other way to quickly and easily compile complex queries and relationships. You will need an entity map and heap to store the map of your objects, to store relationships between them, and you need mapping schema and the way to hydrate the information from persistent layer to your domain models and extract it as well. So you'll need hydrators. You're obviously going to need persist layer, which is one of the most complex parts of any ORM, or the layer responsible of storing your objects in the database. And the most important part is to store them correctly, no matter what order you send them to, and no matter what type of relationships they use. And obviously, you need various relationships to make your ORM have any sense to create. And at the end, you need a ton of tests to make sure that everything is correct, to make sure that your engine works expectedly. Today, I would like to walk you through the persist layer and the dependency graphs of ORM. That's, I would say, a very interesting topic in any ORM, and it usually have one of the biggest complexities in engines like that. So first, we would like to define the requirements for the topological layer we want to create, for the persistent layer we want to create. First, we need to make sure that our layer can topologically sort objects and relationships in correct order. So if I'm saving user which has post or post which belongs to user, I need to make sure that it's always going to be saved correctly. I want to make sure that the layer is going to generate optimal number of queries. We don't want to create tens of inserts or 12 updates when we change one field. We want to use disposable transactions or transactions which we can use, or multiple transactions within one application. So instead of having a global entity manager, we can split functionality and test it separately. We want to have reliable error handling, and we are not only talking about doing the rollback in database, we are talking about not polluting the entity manager when something went wrong. For example, if our transaction failed, we don't want to go and flush the whole ORM to try again. We can just go and recreate that transaction. We need to make sure that ORM has no memory leaks and that ORM can effectively work in daemonized applications or long-running applications, specifically Roadrunner. And obviously, we want to be able to work with multiple databases at once. However, the whole thing, why we even started creating the ORM, is last requirement or the dynamic mapping schema. In our case, we want to be able to define the mapping and relationships between objects dynamically without stopping the application, without generating the code, essentially having the small version of Drupal in our hands. So why are we talking about topological sorting? We talk about topological sorting because the persist layer and your models and relationships between them can be represented as directly a cyclic graph. In this case, each node, ABC, is your database model, user, post, comment, pivot model, etc., where the edge are relationships. This is directed graph. We know which entity belongs to which entity. And in this specific example, it's acyclic, which means we can always walk from one model to another having just one path. Another type of graph is cyclic. In this case, there are situations when model can point back to itself through other models, and essentially you may have more than one way to go from, let's say, A to F. You can go to A, B, C, E, F, or A, B, C, E, D, B, C, E, F. So these graphs have cycles. Before we go to continue writing our layer, let's probably review what Doctrina has. That's very important ORM on the market. It provides a lot of inspiration, and it's been written by many years by many talented developers. The Doctrina sorts, when you're trying to persist using entity manager of Doctrine, it is going to sort your entities using the depth first search algorithm. It is located in the class internal commit order calculator. It is going to sort your entities ahead of the persistence. Specifically, it is going to sort class metadata, and then it's going to invoke the persisters in order of the sorting. All the calculations done directly in the entity map, which means if something fails, you will have to flush the entity map and well start from the refetching. When we try to research this algorithm, or specifically how it happens, we found that this is type of the methods which being called while doing the persistence. In general, that's about 4,000 lines of code just to store your models right. Obviously, it has events and hooks and a lot of interesting additions to make sure that stuff done correctly. When we've seen this thing first time, we was, well, very upset. So maybe there is any other approach. What could be done without creating 4,000 lines of code to persist something? Well, first we need to review what going to be the most common algorithms to perform topological sorting. There is a lot of them, but probably the most easiest to find is depth first. You can see it is working through the graph from top to bottom, and breadth first, which is going from left to right. So what we can do, we can combine these two algorithms to create an algorithm which called IDDFS. Here we go. Or the algorithm which performs the sorting and the execution of your graph commands in iterations, which means it does not have it doesn't sort first and then persist. It's actually doing both operations at the same time. And for us to do that, we have to convert the graph of our models, user has post, so user has post, yes, to the graph which represents command, save user and then save post. And in order to apply this algorithm, we have to convert relationships to dependencies. So we are going to say that there is user command, command to store a user, there is command to store a post, and command to store a post performs, and command to store a post depends on the value of the command provided by user. So this is the visualization of this algorithm, how it works. You can see that it cannot persist the command C first, command C, because it depends on the values of command A and B, so it skips it. It comes to command B and then it comes back. So I hope this visualize what's going on, and the E becomes the last command. We can implement this algorithm very easy, very simple. All we need is the command abstraction, which contains two basic methods, is ready and execute. Command represent the node in our graph, and dependency represent, well, the relationships from between our models. IsReady tells if command has any dependencies which are not resolved. For example, we depends on user ID and it has not been supplied. And execute obviously performs the execution of the command and the resolution of the values to other commands. If you want to persist the complex commands like collections or multiple branches, we can rope them into command aggregate. The dependency or the edge in our graphs is a simple promise. We are saying that command needs to wait for some key and it needs to forward some key after the execution to another command. Based on that, we can sort our graph. We can view a simple example. So we have user, with name, we have post, with title some post. Our post belongs to the user. So what we can do, we can create command to insert user and command to insert post. Then we are telling our post that it needs to wait for the persistence of the user. And then we're telling the user that on persistence, we want to forward the key ID to the command post as user ID, essentially resolving it. To sort these commands, we can create a simple algorithm that's all the topological sorting done in this IDDFS approach. We walk through all the list of available commands, and if command is not ready, we delay in that. That's yield key. If command is ready, which means it has no dependencies, we can execute that immediately. That's all you need to sort commands which depends like that. We can view some real example. In this case, we have a model, again, user, and we have a model post, and we have a transaction which is supposed to save them both. In this example, I put user into transaction first and post second. So during the execution, we are going to convert our graph of models to the graph of commands, which is going to look like the following: insert user and forward user ID, insert post. That's fairly simple. It works right away. There is no tricks. Just go, insert, resolved, and save. We can review a bit more complex example. In this case, we have user, we have post which belongs to user, and we have comment for this post which belongs to the user as well. Please note that this time, to trick ORM a bit, I'm putting the post to the transaction first and user second. So this should force ORM to sort the dependencies properly. Oops. I'm sorry. Here we go. That's how the conversion of the graph is going to look like. It's going to try to insert post first, but it cannot do that because it depends on the user. Then it's trying to insert the comment next because we are doing DFS. It cannot do that as well. Then it's come back to the user, and in another cycle, it completes the persistence. But what about cycles? Well, we spoke about acyclic graphs and cyclic graphs, and for sure they have different implications and different complexity. So that's a simple example of acyclic relationships in ORM. We have the post which has comment, and we also want to store the reference to the last comment in the post. And both of them new, just to make life a bit harder. So how can we do that? The answer is fairly simple. We are resolving the cyclic dependencies at the moment when we convert the graph of entities to the graph of commands. And specifically, the system can see that post has two branches. It has branch to save comment, and it has branch to receive value from comment. So we can split this entity into two commands: insert and update. As a result, we are going to generate 3 SQL queries: insert, insert, and update, and the system is going to work correctly in this scenario. I misplaced one slide. I'm sorry about that. So what do we have at the end? We have the algorithm which is capable of persistent, very complex dependency graphs. We tested very interesting situations when, for example, we have 2 overlapping cyclic dependency graphs in one transaction, and it all was saved correctly. It's fairly small. It's about 8 times smaller than what Doctrina use. It performs sorting and persisting within one process. It can use any keys and any relationship between any databases. It is not linked strictly to the database keys, and we can use disposable transactions or transactions which we can reuse, or we can have multiple of them within the application. So we applied this algorithm to create an ORM, or specifically part of the ORM persistent layer. Our ORM called Cycle ORM, and it has a lot of features which are similar to Doctrine, Eloquent, and some of the features which are not. First, as many other ORMs, Cycle is capable of working with multiple databases, working with them at the same time. It is possible to have read-write connections or isolate databases using prefixes. So you can have one physical connections and multiple logical databases within. It obviously supports reconnects because we run in long-running applications, and it supports at least 4 or 5 different drivers. In addition to that, it can write migrations for you. We have the query builder, which is able to fetch relationships with almost no limitations on nested level. So you can load posts with all the comments and load all the authors of these comments. You can also filter by these relationships, and you can apply different fetch strategies. For example, you can tell ORM that you want to load all users using left join, or maybe it's going to be external query. You can also create very complex selections. For example, in this case, I want to load all the users active true and load all the orders for them using single query or left join. And while loading the orders, I want to filter them by page true and sort them by time created. You can also use multiple relationships while building the queries like that. So you can reference values from one table to another to create very complex queries. Obviously, you can always fall back to pure SQL and do something which ORM cannot do for you. The mapping schema can be defined using simple code. You just define how you want your mapping layer to behave. You can also swap it in runtime without stopping the application or without doing any code generation. If you want, you can also use annotations. They're very similar to Doctrine annotations. In fact, they actually use Doctrine annotations under the hood. So this can be useful for someone who is very familiar with this technique. And in addition to that, we have a very light abstraction for transaction or analog of entity manager from Doctrine. You can have multiple of them, and they only have 3 methods: persist, delete, and run, which allows us to test code very, very easily. It's not much you need to log. Obviously, they can persist all the dependency charts, so they will go deep into the relationships and save all the models. And that's about it about transactions. We do have embeddings, and we have the support for lazy loading embeddings. Obviously, the ORM support value objects and all other approaches how you want to map your data. Technically, you can map your data for any model in any structure. The mapping layer contains only 2 functions: hydrate and extract. And the thing why we did create the ORM in the first place is the support of dynamic mapping schema. Dynamic mapping schema contains of multiple features. First of them allows you to treat your databases and tables as the main objects of your applications. Specifically, we can say that we want to have a table with these specific columns or relationships or foreign keys and indexes. Then we can, in runtime, using, let's say, user-driven configuration, create our mapping. And please note, in this mapping, I'm not using any real classes. I'm using DataMapper, which is going to be using STD objects to carry data, STD class to carry data. So we can do it without any code generation, without memory leaks in runtime. And here we go. I can create user which I dynamically defined, which I dynamically created an entity, and I can persist that in that database. You can also combine this approach with classic models. So you can have part of your logic defined in annotations, in classic PHP classes, and part being dynamically data-driven based on configurations from your users. The simple word example, when your customer asks you, can you give me a button to actually add the fields to models by myself? The performance of ORM is pretty good in some cases. We do lose to Doctrine on the Persist. Unfortunately, we have the transaction, we have a bit more heavier transactions, specifically because we isolate them, so we don't pollute anything up. But we do win a lot on the eager load and find by primary key, so the selections are well optimized. The complex queries or the performance of the ball layer is about the same level. But Doctrine wins here just a bit. The ORM we created called Cycle, it is available on the following link. The ORM distributed based on MIT license, so you're free to use it for any commercial or non-commercial projects. The code base is about 8 times smaller than Doctrine. That makes us happy to maintain it. For us, this is number 4 generation of ORM. We created multiple iterations before that over the last 10 years. And this ORM is available in Spiral framework. It's out of the box and will be available as one of the base ORMs in UE3 framework as well. As company, we do support this ORM officially, so it's not pet project. And if you have any feedback or any issues, please feel free to create them for us on GitHub. The links from this presentation are available on the screen, but I assume the presentation itself will be available for you as well. Thank you for your attention.
Thank you so much, Anton. That was fantastic. We do have a Q&A room. You should find the Zoom link in the chat if you would like to join us for some Q&A. Anton, if you want to hang out for just a little bit longer, we'll pull the questions in from the Zoom room. If you're in the Zoom room, make sure to mute the stream so that the audio doesn't come in through the background. So while we're waiting on those questions to come in, Anton, I have a question for you. What is the backstory of Cycle? How did you decide that PHP needed a new DataMapper ORM? Can you hear me?
I'm sorry, I cannot hear you for some reason.
Oh, okay. I don't know if my audio is coming through for everyone else.
I can hear you now.
Oh, there we go. Awesome. Thank you so much for the presentation. I did have a question for you as we wait for the other questions to come in from the Zoom room. So what is the backstory behind Cycle? How did you decide that PHP needed a new DataMapper ORM?
Well, it's fairly trivial. We have the multiple projects with the similar requirements. This requirement, which I described as dynamic mapping schema, basically the projects for the social studying, when we need to define the kind of data dynamically, we just cannot hard code it. We tried to look around. We found that this can be achieved in the Java Hibernate. So it can be achieved in Python, in Python SQL Alchemy. But unfortunately, doing the same thing in Doctrine was fairly problematic. Since we already have the ORM on our smaller projects, we just rewrote it, improved that, and well, I'm not going to lie, we looked a lot to the Doctrine. We tried to see what features they have, what milestones in Doctrine 3 they have, so we won't repeat the same cycle, and we just try to create ORM which kind of future-proof a bit.
Awesome. Fantastic. We actually have Konstantin ready with a question, I believe, from Zoom.
Hi, Anton. Thanks for the talk. While we are waiting for other questions, I'll start. What the types of projects best fits your Cycle ORM? Because we all the world PHP know Doctrine and uses most of the time. But if you start a new project from scratch, what type? The decision should be use Cycle?
Well, I would say the project similar to ERP, CRM, or CMS systems. Basically, any project when you might need to store the data which is configured by the customer. Let's say, you have users and groups, and they have phones, and the customer comes to you and saying, you know what, in my version, I actually want to have secondary phone and work phone, right? And you can see at the set eyes of the developer, which needs to go back to the models, create them, make migrations to make it work with this customer. With Cycle, you can do that all well, using simple interfaces. But in general, we consider that as, well, kind of replacement for Doctrine, at least for our projects. So any place where you can use Doctrine, you can use Cycle as well.
Okay, great. We have some other questions. One I think is good for life is from Yulia Sergeyevna. What is the largest database in production that was managed by CycleOrm? And what projects use it in production?
We have, I mean, almost every project in our portfolio been using the past generation of this ORM. This one has not been used by us on their top large projects, but a couple gigabytes database we use it for stock marketplace, so selling images and photos, and we use that obviously.
Yeah, no sound from Anton.
Hello.
Yeah, you're here again.
111.
Yeah.
Well, we using this well, previous generations all the same ORM and same approaches for the up to 5 gigabytes databases in production, not very large, obviously, and we use this one on production for the e-commerce projects, well, up to gigabyte size databases, not super large.
Yeah, great. What type of databases it is? Postgres, MySQL?
It's
Oracle?
MySQL and Postgres. All the
Yeah.
recent projects we created are on Postgres.
Yeah, great. We have another question from Evgeny Leonovich. Is it possible to create your own non-PDO database debug driver for CycleOrm? Is it really needed?
Drivers are, well, I'm not sure it's needed, but it is possible. The drivers are isolated fairly well. In fact, when we've been creating the ORM, we did create an ODM for MongoDB back in the day. So a lot of the concepts in ORM leaves a lot of the room to replace the persistence and selection with non-SQL databases at all. So one of our plans is to create a MongoDB driver as kind of additional extension for the ORM.
Yeah, okay.
Excellent. Thank you so much, Anton.
Hello.
Yeah, if you have some questions, please turn on your cam, sound, mic, and ask a question. Anton will.
I think we also have the question from Sergey in a chat. The dynamic mapping is also in Doctrine through the load class metadata. For example, Aura CRM is using that. Yes, we've seen this mapping in Doctrine. We even try to use that. One of the limitations of Doctrine, which we found during the dynamic mapping, is that you still need to have the physical class implementation in your code. Otherwise, you won't, I mean, so you can extend the existing models, but defining new models would be a challenge. Plus, finding documentation for that was fairly problematic, so my guy just gave up on that. So essentially, our goal was to make the dynamic mapping as a first-class citizen in ORM.
Yeah, great. While other people are waiting, writing their answers, does CycleOrm support multiple databases and transaction spread across multiple databases?
It does. It does support multiple databases. It can have overlapping transactions to persist data in all of them at the same time. And specifically, we created that kind of command model in a way so we can actually run it in distributed applications as well if needed. We did not have a chance to do that, thankfully, but yes, we can run them through the multiple databases.
Yeah, great. Another question is, should I use CycleOrm to write or execute some complicated SQL through it? I mean, most of the time, all ORMs have problems that when I need to write a really complicated query, it's rather easy to write in somewhere in SQL, just call and receive the answers. What about Cycle? You show us examples of how it's quickly.
You can, the question here is like, yes, you can write the complex SQL queries, but to map the results of these queries to your models, you will need to create some bootstrap code to explain ORM. which selected field correlates to what. We have examples in documentation how to do that. It's not trivial, but it's not that hard. So you can write these queries. I'm not saying that it's going to be painless. It's ORM, so no ORMs make SQLite painless.
Yeah.
I think someone asked about regarding the complex SQL, I can give you an example. We run one of the inventory systems on this ORM, in which we have to do the atomic inventory changes and transfers. So doing that require like pessimistic locking and atomic moving between tables. So we combine that with native PDO transactions with ORM, and it works fine.
Okay. Another question that we missed from chat was, do you support Oracle and mostly large objects, big files storing?
Sorry, plan?
Does CycleOrm support Oracle databases? And
it does not support Oracle databases at the moment. We do not have the customers which asked for that, so it's not in a priority.
Okay.
But we are free to, we are free the community, if community want to do that, and if it's really pressure thing, we can add it.
Yeah, great. And CycleOrm support, does CycleOrm support lobs? I mean, large object files. Maybe in Postgres it's just a byte array. It's not a problem.
Postgres will respond as a source. So yes, it does. We don't use them, but it does.
Yeah. Okay. I think I missed another one question. That was how to migrate from Doctrine, and what are the key bits and any reason to do so.
There is. I see multiple questions as well. How well is Cycle suited for big batch operations? Any big batch operations in any ORM, especially DataMappers, is going to be painful. We try to isolate transactions so you can flush and recreate them. Is identical to the Doctrine. But since the nature of our applications are all long running, we don't stop them for months. I mean, it's okay. You can use big batch operations, but you need to split them into a bit smaller batches if you could. I would probably recommend not use ORM if you need to persist more than 100,000 objects like in a one simple form. Any ORM for that. Do you have plans about creating modules for several frameworks? Yes, we have plans for doing that. We have already created, UE community created the module for UE framework. We obviously have it integrated in our framework, but if community demands, yes, we can surely add that. It's very easy. We have the Bootstrap repository, which allows you to roll up Cycle in about 5 minutes. Does it support features like materials views? Yes, it does. You can have nested queries, you can have CT, but it does not allow you to define them. You can only use to read from them. We also did not test I'm not sure that persistence is going to work because it won't. So if you have them, it will work because it's going to treat them as just normal tables. Yes, we do map the datatime object, and we map all the datatime objects through the DBL to the time zone defined by the DBL layer, specifically UTC. So I'm not sure if it answers the question, but all the dates are being normalized into UTC or any other time zone you want to use.
Yeah, great. Are there any other questions? Please raise your hands. Feel free to ask. Also, while we are waiting, there are composites primary keys supported in the current version?
Not yet, but we are actively working for that. There is a ticket on GitHub. We completed 9 of the 16 steps to make them work. So it's work in progress. This is one of the weaknesses we have right now. Kind of. We don't use them, but this is something we should work on.
Yeah, great. Yeah, we have another question.
What about entity hierarchy? Yes, it is supported. You can use single table inheritance. Is it possible to map multiple models to the same using cycle? Yes, it is possible to map multiple models to the same tables or multiple tables to the same model. So you can do that. I mean, you can do whatever you want because the mapping layer is fairly thin. So, you can use models which are not classic PHP classes, like we can use STD class objects. You can create models just for your domain layer. Technically, we have an example of how to use an ActiveRecord-like pattern when the model contains the transaction itself. So you can map them in very different scenarios. The main disadvantages for CycleORM, it's new. It's new, so we don't, I mean, even us, sometimes we find an interesting patterns which good or bad to use. We try to test it well, so we're fairly sure it is stable, but it doesn't have all the features which always demanded, like composite primary keys is something which we lock on. There is a huge field of optimizations. For example, between version 1.1 to 1.2, we bumped the performance for the selections by 25%. It was decent amount of work, but the benefits are very well seen for us. So we're pretty sure that there is other parts of the ORM which can be well optimized. So when we have the ORM like Doctrine, which is for 12, yes, we have UUID support, which is on the market for 12 years. It's very hard to beat with them since a lot of people optimize all the little aspects.
Yeah, how many developers work on this? I know that you work on Cycle for a long time. Are there any of your colleagues?
We have a couple people who is helping me to develop the DPL. We have a couple community members who is helping to find bugs and optimize the ORM, but mostly that's myself. That's what I'm responsible in the company and in the product line. For search criteria on repositories, very limited, doesn't work on association. Do you plan to support any strategy-like search criteria for repositories? Well, you can search by relationships in repositories, including very, very deep relationships. I'm not sure about this aspect of Doctrina, so I cannot answer that correctly. But I would say partially yes, but I need to see the use case. You can have a very complex selections with, I mean, almost every relationships in your model.
Okay. Are there any other questions? Please ask them.
I think I can also say another disadvantage of Doctrine, of CycleORM is since it's fairly new, we do not have the hooks or events added to that. We're trying to avoid things like that. So many things like, okay, let's add trade for timestamps in other ORMs. Here you will have to write a couple lines of code in a mapper to make it work. So in order to keep ORM simple and easy to maintain, we cut some called behaviors from it. We do not have caching as part of the ORM. This, in our opinion, is not part of the ORM, but we have at least 3 places where the caching can be very easily added. You can cache it on memory level, you can cache it on repository level, on database level, or you can fetch all the data tree from the database, cache it, and then hydrate your models post factum. So we do not have it on core level, but we leave enough abstractions to make it happen easily.
So I think that the main idea was to just develop ORM itself, almost needed parts, and to distinguish between other models that can be handled.
Yes, we're not trying to put everything which we can put to ORM. Like if you compare the size of Doctrine, I mean, biggest part of that is obviously Persist and DQL. Doctrine is about 18,000 lines of code. I think Cycle about 2,000 lines of code. And I mean, we're just not feeling comfortable maintaining and supporting the huge behemoth. We just want to have something simple, which just reliably works and which doesn't change API often. So having small ORM and everything else as extensions, at least that was our plan.
What are your main plans for near future of the cycle? I know we already heard that about composite primary case support, some other stuff. What maybe your insights?
We want to add as first-class citizen support for optimistic locking. This can be done now using custom mapper, like 10 lines of code, but we want to edit out of the box. We are seeing at least 12 or 15% of additional performance improvements we can get with memory reduction, so optimizations and composite primary keys is something we want to focus as well. In addition, we want to add ability to use different collection types for different models. So if you're fan of eloquent collections, you will be able to use them with your models. Right now, we stick to the default Doctrine collections.
Yeah, great. We have another question from Sergey. What about creating a CycleOrm bundle for Symfony?
Well, we are not using Symfony, unfortunately, but I think I've seen some repository which try to do that. I'm not sure if it's alive or not. So community has been doing that. If you review the docs or Bootstrap example, the integration is fairly simple.
Great. Are there any other questions, people? Please. I don't see any other. So, Anton, thank you for your talk, for your awesome work. I wish you good luck and to spread this CycleOrm through all the community. By the way, we have already started another talk on our live stream. So please see you there. See you soon. Thank you all. Bye.
Thank you. Bye-bye.